Hello, everyone, and welcome to Jozi.js July. We enjoyed the last one so much, we did 2 in July, although that's primarily because, I don't know, calendars are weird and stuff. So we have a code of conduct, and by watching this, well, I suppose not by watching it, but by communicating in the chat and on our meetup page, we expect you to be nice, be respectful and constructive with one another, to work together, because we're all here in a common cause, and please to respect other people's space and not be spammy. If there are any other violations of code of conduct that you think you see, please feel free to contact any of us. You can do so on Meetup or via here. We have to thank our sponsors. We couldn't do this without them. So thank you very much to Innocent, our stream sponsor, and Microsoft, who sponsors our Meetup page. And we're a part of the Azure Tech community, which we appreciate. Thank you. So today we're here to talk about architectural patterns that we think you should know, which is really broad. And I suppose the first thing we need to ask about is like, well, what is this thing that we're going to talk about? What is architecture even? And it is really ambiguous and poorly defined. And if you ask 10 people, you'll get 11 opinions about what architecture is. Now back. So you'll have to also forgive us. We're trying new stuff here, and Jerry and I are out of sync. So I usually define architecture, and I think it's a commonly accepted definition, as the architecture of any system is the stuff that's hard to change. And I think that's a really simple rubric to figure out which parts of your code is architecture and which is not. What we're going to be talking about tonight is mostly lived experience, and you're not going to find any kind of book architecture here, so don't expect that. Because as we all know, the collective noun for architects is an argument of architects. And hopefully we'll keep that to a bare minimum, and all of our conversation will be constructive tonight. So we discussed and thought long and hard about which architectural patterns we think are like the 3 that we can cover really, really quickly, that are relevant, that are basically the essentials. And not all of these are equivalent. They don't even play in the same space necessarily, but they're ones that we feel like you kind of have to know. And the first one we're going to talk about is model view controller. Then we're going to talk about Flux patterns and their derivatives. And then lastly, hopefully we're going to cover event-based architectures such as PubSub. But to kick us off with discussing or introducing, so we can discuss, model view controller is Jerry and Lucky.
Sorry, I was muted there for a second. Thanks, Mike. I think we probably have the easiest job tonight. And I say this because MVC is probably the most popular of the architectural patterns. It's the one that I've seen the most in my personal experience. And again, the kind of systems that I get to look at are very big, old systems that either live in a bank or some sort of old government entity, right? And basically, MVC is firstly old. It was invented in the late 70s, and really it was brought in to solve the problem of having way too much data, large amounts of data that are very complex for the user to deal with. And it tries to solve this problem by really separating the concerns of our application, putting the brains in one place, which is called the controller, and then splitting the data as well as what the user ends up seeing. So the 3 parts of it really are the model, the view, as well as the controller, in which the model is concerned with the data and how the data itself is represented on the data level. The view would be what the user ends up seeing and really interacting with. And all of this is brought together by your controller, which is also where you would generally facilitate your business rules or put in your business logic in order to make sense of all of these floating parts. So an example of this, Jerry, do you mind just giving us a brief example how these would come together.
Cool. So this is one simple example that I've always used to explain MVC, and I think it's a good sort of small and short description that can kind of explain it very well. So we have that picture that Lucky just walked us through. And if we take a look at the model, so say we have, oh, there we go. It was being slow. We say we have a model of data, some sort of data. We have students and we have classes. And the purpose of our system is to assign our students to classes. The model will be the place that defines what a student looks like. So a student will have a name, they'll have an age, they'll have a date of birth, they'll have some sort of registration number for the school that we're building. And then our class will also have a name, it will have the dates that it happens on, the description. This is all going to be defined inside our model. Then we'll move on to our controller. Our controller is the brains, like we said. That's where the business rules will go. All of the things like getting the student information from the model, getting the class information, adding a student to a class, all of that kind of logic would go inside the controller. And lastly, we'll have the view, which is the visual display of those properties. And like we can see in the picture, the view and the model don't talk directly to each other. The view is a representation of the model, but the data that we actually see in the view goes via the controller. So the controller will get it for us from the model and send it to the view in order for us to be able to see it. So we'll still have a student and a class, but it will just be the visual representation of the model. So, as Lucky said, MVC has been around for many years, and we've seen it in use in many systems and a lot of different frameworks. .NET for a very long time, Java, all of the famous frameworks, even Angular 1 is MVC based. And here we've listed some of the pros and cons of MVC. And Lucky already mentioned a couple of these, but do you want to talk through the rest of the pros?
Sure. So when we talk about architectural patterns and even design patterns, really, I think back to my first professional experience of working on a system. And one of the things that frustrated me when I started was, if I need to get that piece of data, why do I have to go through all of these other channels when I could just create a direct link and get that data? And that's because I didn't really understand what it takes to put together a big software system. Writing code is easy. I think we can all write code, but building software, that's where the difficult part comes in. And what MVC has, or from my perspective, some of these benefits include being able to really separate your concerns, because by decoupling what your view and your model sits and having that business logic in one central place, some of the benefits of that are that firstly, you don't repeat yourself. When you have to change a core fundamental business rule, there's only one place that it actually lives. And all of this information is actually funneled through that one channel. It has proven to make maintainability slightly easier than if I just written everything in a monolith manner. And it also supports being able to have multiple different views, because they all speak to that same controller that then still enforces those business rules. And despite not working on too many systems that have full end-to-end testing, it also makes testing each one of those components individually possible and much easier. Some of the cons, Jerry?
Yeah, so that does make MVC some of the reasons why MVC is one of the most popular frameworks out there. But there are some downsides to it, even though it's been around forever and everyone uses it everywhere. Usually, as a first attempt when building systems, people just revert back to MVC. There are some problems with it. And the first one is the complexity of it. Like you said, you just want to do the thing, you want to skip all of the steps. And if you're building a relatively small application or something like that doesn't need all of this extra boilerplate in order to get started, it can be a little bit complex to get done. And the inefficiency of data access in the view. So the view has to always go via the controller. You can't just, get the thing onto the view easily. Those are some of the cons of MVC. But Mike is laughing. I'm sure that the rest of our panel has some more things to contribute to our very short intro to MVC.
I have feelings.
What are your feelings, Mike?
So, I'm going to share my first feeling. And my first feeling is that I use, and perhaps it's where I come from and how old I am, but I use MVC as like the Rosetta Stone between frameworks and languages. So if I'm learning a new language, the first thing I'll do is I'll find whatever the de facto standard MVC framework is. And I'll be like, okay, cool. Let me use a paradigm that I understand. And then I can get to grips with how the language needs to be used idiomatically because I understand MVC.
Mm-hmm.
I think if you work on web, you have to know MVC, right?
Definitely.
And I'm going to give other people a chance as well. But the one thing we haven't scripted this stuff, folks. We haven't really shared opinions other than who's going to introduce which sections. I don't agree that MVC is a high complexity to start. I think MVC is ideal for simple applications where there's a very well followed pattern. You don't have to think about the pattern, right? You just do what it says on the box and follow the draw in between the lines, and there's a very easy thing. I think the problem with MVC is when it starts getting complicated and you've got lots of routes and lots of pages. So in terms of scaling it up to hundreds of routes, it doesn't work very well at all. It's unsustainable, in my opinion.
Yeah, that's been my experience as well. Everything all starts off idyllic and everything is going well and you're like, oh, this is so great. And then, if you've worked on MVC specifically in something like ASP.NET, they've introduced this thing called areas, which is kind of I say they've introduced, it was about 5 years ago. But it's like a way to sort of encapsulate separate domains and that sort of thing. And it just shows you that that's one of the symptoms of the problems inherent with MVC. And then, kind of is it really worth it? Because the beginning of the project is never the hard part. So an architecture that makes the beginning, the easy part, easier is fairly low value. You kind of want to look at building systems a little bit more long term, and I don't feel that MVC is really good at that.
So considering the fact that scalability is such a big problem with MVC, why do you think that it has lasted this long? And why do you think that it's still such a popular
I think it was
great question.
It's probably also, it's got different interpretations. So I think the diagram that you guys showed, it had all of the traffic going through the controller. And that's cool. I think that's MVC when you're dealing with the server and client side. So if you have, so my first introduction to MVC was Django. So it's the models, that's the database, and then your views are things that just generate some HTML, and and it all makes sense, and that's fantastic. like looking at how Facebook used to use MVC, it was like completely bananas in comparison. So they had like the controller sitting over here somewhere, and then they've got the models, like lots of models, and then lots of views, and the views are all talking to the models, and the models are all talking to the views, and it's bi-directional and weird looking. And yeah, so I think like a lot of the so I think that with that implementation, there's a lot of complexity and cyclicness. Yeah.
So
Well, I think that's a changing the guard thing, right? Because you can call it model view controller, but that doesn't mean that it's model view controller. You can name anything. And I think, and like we use the example of Angular.js, and I think they got themselves into a lot of trouble because they relied very heavily on the model view controller metaphor. And then the more advanced and more adopted Angular.js became, and the bigger applications people started building, the more they realized that, damn, this doesn't actually work for how people are using the framework anymore. I see Ruddy nodding, sister. Let us know. I can see that nod.
No, it's to answer Lucky's question. It's just like it first was easy to start, and then everyone discovered that it doesn't scale. So the problem, or at least it's complex to do so, and that's why companies like Facebook then decided to go a different route. Is that to answer you, like as we all started, is like logically model view controllers make sense to me. I believe that they are isolated. I believe the communication is happening as I should. My view is getting the information. My data is separate. I'm happy. But we never saw the future when the things started being complex. And that's when, oh, okay, everyone had an oh moment. And I think most organization and most application, as soon as they switch the point from being simple to complex, they have that oh moment.
Yeah, one thing that I think, like what Sheena was saying, and I think it's one of the problems with MVC actually, is that because when people started growing out of MVC, they found other ways. Everyone found a different way, which wasn't really like documented in any pattern, and sometimes that's okay, right? But for understanding something, like going from someone who's found one way to scale their MVC to going to someone who's found a completely different way, like you struggle to understand that kind of stuff, you know. It's just like, why call it MVC anymore if it's going to be that different?
And just going back to Lucky's original question about why is it so popular, why hasn't it died yet? I think if you look at Spring, if you look at ASP.NET, if you look at like Ruby, Django, all of them come with an MVC implementation out of the box. And a lot of the beginner tutorials are built around that. So you're like, okay, this must be industry best practice. So you get started on that. And by the time you realize that you've gone too far, you can't turn back without rewriting everything. So I think that's why we see it so pervasive.
Although I don't know, man, I've written a lot of really useful systems that have done a lot of useful things with model view controller. I will defend it as my de facto go-to to the death.
It's also one of the reasons we chose it as as an option today, because it is something that we all thought that it's a pattern that all web developers should know.
Okay.
Yeah.
Like when we get to the next ones, like the next patterns, Flux and events, those are a lot more complex. They're not the kind of thing you can teach a student, necessarily.
Absolutely. And the other patterns that we talk about, like they come around for a reason. So they're a lot more confusing, but they exist for a very particular problem they're trying to solve. Yeah. MVC is it's very basic in terms of that separation of concern and then like how the web was designed to be used. And it gives you all of the ingredients. It's like making cupcakes, right? You just need these few ingredients and then, hey, you've got something that is bite-sized and amazing and it tastes good and it makes you feel productive.
So MVC is like the box mix.
It is the box mix.
Yes.
Literally, right? Like you download the framework and you're like, file new. Oh, awesome. I guess I'm going to create an MVC.
I have a website.
Yep. And so the idea of... sorry, go ahead.
Rudy.
The ideas of these conversations that we have involve viewers as well. Obviously, for us to share our thoughts, and not at all to say that this in itself is a bad pattern. The idea is that we interrogate the things that we find uncomfortable with them and things that we've learned out of it. But this still has a place, and that's why it's still used and has a purpose with whatever scale that application might be, but still has for people to pay attention to it and learn what it's about and understand it.
Yeah.
No, understanding MVC is very important. I think something that what Mike was saying earlier with MVC, when you learn a new language, you start with the MVC framework. And thinking about it, I've done that too. I've gone into a language and like if I can't find an MVC framework, I'm like, I can't learn this language. I can't, just don't want to.
Okay, so we've got a question. Okay, and that question, Tabiso, I hope you don't mind, your name's on screen. So in the world of serverless, don't you think the MVC concept is well practiced? For instance, if you have your AWS Lambda function, API gateway, and S3. Okay, so it's taking a look at the paradigm, I suppose, in context of next generation deployment infrastructure. So it's a very good point and a very good question, because a lot of people are looking at, because the things that you highlight, barring potentially the API gateway, are largely free, right? So you can write a close to model view controller application, except using free stuff or relatively inexpensive stuff that's commoditized and cloud native. I think, and I don't know what your feelings are, but I think that I would not, I think through a lens, you could build something that was MVC adjacent, that followed the pattern of MVC. And I agree with that entirely. But like when we're talking about MVC as being the ready mix, that doesn't taste like ready mix, right? That tastes like I'm making my own cupcakes from scratch. How you folks?
Yeah.
So one last point before we move on, and I'm sorry, like I love MVC, I really, really do. But like it's a question as much as it's an opinion. When I was learning MVC, one of the idioms that was used around it was fat model, skinny controller. And basically what that meant is taking all of your business logic, or as much as possible, outside of your controller and putting it all into your model, and having your model be an object that knew how to operate on itself and load itself, etc., etc. It was testable. So in some senses, in my head, in that early MVC, or early modern MVCs, so mid-2000s, because it's an ancient pattern, the idea of MVC being linked to object orientation was very firmly entrenched.
Mm.
How do folks feel about that?
That was actually something I was going to mention as well. I also feel like other forms of programming don't really match the MVC pattern that well, whereas object orientation does very well. It just works. The way that, like, if we think about the probably two most popular MVC frameworks are Spring MVC and .NET MVC. They are both object-oriented languages.
So on that note, Jerry, I mean, let's put a pin in that and just like highlight that this is a point that we're going to discuss after the next presentation, right? Because we're going to time box the stuff, because otherwise we can talk about this thing in an uncontrolled manner.
We can talk about MVC for the whole hour.
and I think about contrasting this and what we've just spoken about with the next pattern is really, really important. So let's hand over to Sheena and Rudy to take us through Flux pattern.
All right. So Flux came about or was popularized by Facebook. I don't actually know if they invented it or not. In their architecture, they had a whole lot of troubles with a weird MVC-ish thing that they were trying to do. And led to all sorts of cyclical dependencies and unpredictable code and that sort of thing. So their main issue was around having lots of bidirectional data flows that could affect each other, and it caused all sorts of trouble. So Flux. Basically, the idea with Flux is that it's a unidirectional data flow. So you can see that there is data going backwards, but we'll get to that. So basically, we've got these things called actions. And actions are little, you can think of them as, in different implementations, I'm sure they're different things. In like Redux is the most common implementation. Rudy's going to talk about that a little bit later. But yeah, in Redux, like the actions are little tiny JSON objects. And that's quite nice because they're like very small, simple things that you can pass around. You feed them to a dispatcher, and the dispatcher is something that basically controls the flow of information. So it doesn't allow lots of things to happen at exactly the same time. So the original Flux would only allow you to have one action at a time, and then it would like, if you try to get it to do too many things at once, it would just kind of fall over and break. But what's cool about that is that like, you can't like start a new action until the previous action is finished resolving. And that makes your code like much easier to debug and to test and to reason about and all of that. The next part is the store. So the store is like kind of like the model in MVC. So that's where the data lives, and it's not super intelligent. It just kind of knows about like how it needs to update itself based on different actions. So if you had a house that you were trying to do cool stuff with, and you wanted to have an action that turned the light on, then your store would be like, oh, cool, I got the turn light on action. I'm just going to change that over there to a 1, and then life is good. And then the view is very much like the view in MVC as well. So so with this, you can have lots of different stores, and you can have lots of different views as well, but you never have data going from the view back to the store. It's always like action goes to dispatch, goes to store, and then the view can make more actions if it wants to and send them back to the dispatch. So that's pretty cool, and it's got a bunch of benefits. In the next slide, a bunch of pros. So as mentioned, like the one-way data flow does make things a lot easier to reason about, test and debug. So if anybody here has worked with Redux before in the browser, you can like almost time travel in your app. You can, it really helps a lot with debugging. Then because of all the actions going through the dispatcher, you don't have any strange cycle things happening. The things are quite orderly. Like you can also add on things in different implementations. You can add on middlewares to make your dispatcher a bit more awesome. Then it's way more scalable than MVC. So scalable in terms of complexity. So if you have an app that does like a lot of different things, then this is cool. And then the fact that the actions are so simple and serializable, that opens some more doors. I mean, you could store the actions. The actions are things that you can send over a wire if you wanted to. So it's like quite, it's quite malleable like that. Over to Rudy.
Awesome. So if you don't know Flux, but you know Redux, then we can all forgive you, because Redux is almost like a one-to-one match with Flux, but Flux is actually a pattern that can be implemented by different libraries, which have been implemented by libraries. The first one, which is the common and most famous one made by React, or made famous by React, is Redux. So based on the conversation that Sheena just like highlighted, right, is that Flux usually has the action in the dispatcher that sends information to the store and all of that. Redux and all the authors of Redux looked at that and was like, okay, we can make this a little bit simpler by replacing the dispatcher with the reducer. And this is basically what it still follows the unidirectional flow of Flux, but they've kind of made the all around trip a little bit shorter by using the reducer. And there's quite a lot of things that's packed into Redux, but yeah, we'll get into that a little bit later on. And they also have a centralized store. The other three one that you might not know about, or maybe you know about, but I'm just going to highlight it anyway. So Reflux, it removes this dispatcher entirely and allows the actions themselves. So if ever you remember the diagram in the previous slide, for them to be able to dispatch to the store as needed, because then the view will say, hey, this is what I'm doing, and the actions would be a lot more smarter into carrying that data and sending it to the store. And then the other implementation of Flux is Alt, which has a very weird kind of concept with their actions by just firing and forgetting and not having to do anything with it. Be like, okay, cool. This is the action that I'm going to dispatch or release, and I'm just going to allow everything else to take care of itself. The store has no setters, and maybe this might not mean anything to you if you haven't implemented anything like a store. But yeah, and it also has a single dispatcher. And then the other very famous one, and according to the Flux Facebook article, is MobX, which was new to me when I actually heard about it. But like, it's actually very commonly used from what other people say, which I was like, okay, cool. It's based on a reactive programming kind of paradigm, which is very interesting because the state itself has like observers to know whenever information has changed, and then it will dispatch that information everywhere else. So it eliminates the complexity of always trying to tell a certain action to say, hey, go do this, but states will be in charge of the data. And when that data, because they will wrap that store with an observable, will observe when data has changed and dispatch the relevant action, which I found very, very interesting. Anyway, these are the few Flux implementations that you'll find around. And as though we might make Flux sound interesting and awesome, it has its cons. And I went to town with this one. So give me space. All right, one of the first ones, right, is that something that Mike actually mentioned a little bit earlier on, that once you have chosen an architecture, which is very, very true with Flux, it's very, very hard to rip that out and having to implement something new, because it's very specific about how information flows around, which is also almost an unnatural thing if ever we are coming from a world of MVC and all of that. And the conversation that we just had about MVC is that it's easiest to start. That's not true with Flux. Flux has a lot of boilerplate, has a lot of things that you need to put in place to make it work. All these states and stores and actions that we're talking about, if you've implemented an application in Flux space, there's a lot that's involved for you to actually get started. It can also get unnecessarily complex, especially if ever you have a view that maps to a store, because the lines are not clear between to what point do you start creating a new store for a specific view and all of those things. So that could also get a little bit complex. It makes simple changes a lot more elaborate, if ever I might say. Like, you can't just change one thing and be like, okay, now it works. You have to make sure that the action is being placed in the right place, being dispatched in the right store, getting the right information and all the way to the view for a very, very tiny change. The other part is that stores can be very lengthy and hard to read at some point, because people might not know the part at which they need to split to a different one. So everything might be in one file. Those files can get to very, very long lines. And when I started investigating about this topic, this I found very interesting, because even though it might not be a disadvantage for other people, I've actually experienced this. So if you look at a state file, you can actually see the different types of actions that affect that specific state file. But the other way around thing is not true. You can't see, if ever you had dispatching an action, how many state that action actually affects. So you can go and search in your IDE where like a similar constant you've used in the action is, but it's not an intuitive and less like cognitive load to actually see that. Another very, very big thing, which I think a lot of the Flux implementations really try to make a little bit easier, is the wait for that comes inherently with the application. So if you remember what Sheena was talking about, is that you have to have an action and you have to wait for that action to be complete before another action is dispatched. There's so many problems with this, because sometimes you can have multiple actions that are actually dispatched in parallel, and you need to figure out which one has the queue and is waiting for the thing to run, and that needs to end first before the next thing comes about. And this based on a previous job that I have performance leaks with the redux of the Flux implementation pattern, but we have something called should component update. And just like a young level explanation of this is like, at some point when a view needs to change, your component needs to re-render. The calculation at which you actually see what has actually changed and what is affected by that change can propagate to different parts of your view, and things that don't necessarily need to update will update. And this part and this calculation and this complexity results into a lot of performance in your application. And last but not least, because there's so much involved in Flux, the learning curve for it might be a little bit steep compared to like other patterns like MVC. So it might need you to be a little bit involved when you need to start using it. So yeah, these are the thoughts. And now we have to talk about pitfalls, thoughts from people, and how you can actually overcome these.
Yeah. So the slide is just like, I think everybody who's used Redux has probably also misused Redux, because it's like, as Rudy says, it's a weird thing to learn. It's not that intuitive. Like, the official tutorial is great, by the way, it's really lovely, but you start reading this thing, it's like, here's an action. It's like, okay, it's like, what is this for? So I think there are a lot of pitfalls that people can fall into, especially with Redux, that I've fallen into. And I'm not sure if I should go through all of the stuff or if you guys just want to like discuss. Okay.
We can discuss.
I'm chomping at the bit to go, so you tell me when you're ready.
Okay, cool. All right, sweet. So like the one thing that I found, like one of my earliest lessons was just about the shape of the store. So the store itself is like a JSON structure. So there's a lot of stuff around it, but in the end, the part that you control is just like a JSON object. And you like, as an example, like I was writing this application that dealt with surveys, and it'll be like, here's a survey, and the survey has questions, and the questions have like types, and this one can have some options, and da, da, da. So like a form thing. And so I was like, cool, I'll just like represent a survey in its entirety in this like highly nested data structure. And then when we press this button, this piece down here somewhere is going to change slightly, and like lots of ellipsis dots. And that worked fine, except it was really, really slow. So there's some tricks around just structuring your data nicely, like making things nice and flat. So if you have a survey with lots of questions, you can have like a survey with lots of question IDs instead, and have the questions down like elsewhere in the store, and then things are way, way faster. I think like another thing that is actually a real con of the Flux pattern is it doesn't really have a good idea about how side effects work. So like asynchronous things aren't really that well represented. So like it's not built into the core product, and that's true for Redux as well. So you have to be like, thanks exist and Stargate exists, so you have to pick one of those. So that's good. Well, they are useful things. My preference is Saga because, again, flat is better than nested. One other, like another thing that people bump their heads on is the fact that sometimes you want to dispatch an action that has functionality that overlaps with another action, and then suddenly your stuff isn't dry anymore, and you it just ends up being a little bit confusing. So for me, a way to overcome that is actually to use something that can deal with those side effects. So just like have an action that gets picked up by a middleware that can deal with making more actions, and then you can just like compose your actions, and that works pretty well. Another thing that people do is sometimes they'll make like one gigantic reducer to just like control all of the state in like one file. And if your application gets big, then suddenly your like your scalability goes out the window because it becomes a bit hard to manage. So yeah, it can become quite challenging. So like naming files and functions and all of that is pretty hard. It's like kind of a challenging problem if you want to keep your code like nice and clean and scalable. And it's kind of hard in Redux as well. So there's this thing called the DUX pattern or DUX approach to Redux, which is pretty cool. I recommend that if you're looking into doing some like Redux on an application that you want to scale, then you probably want to look that up. It makes your stuff like nice and clear and cohesive, but it also adds a whole lot more boilerplate. And then I think this was a con that Rudy mentioned. Like, if you, it can be pretty hard to like reason about where different reducers should go. So like let's say, for example, you have a web app and you have people can log in and different users have different rights. And so, I don't know, different things show up in different colors, who knows? Like, where should that information go? You need to do a little bit of thinking about like which reducers you need and which views need to access the stores that are managed by or parts of the store that are managed by the different reducers. So like, it's something that you should probably think about early on in your application development, because otherwise things get a little bit untidy. Yeah. And then last but not least, simple things become complicated. So like, if you're managing data in a front-end app and you want to make, like with Redux, and you want to make an API call, like, it's not as straightforward as you want. Like, you want to know that the thing's underway and then show a cool spinning donut, and you want to you want to know if it was a success or a failure, and you want to be able to get access to like error messages that were sent by the server, or like success messages or update state as a result of the like successful API call. And it's like, it all gets like not that straightforward. And the same thing with dealing with forms. Like, there's a lot of like weird complexity there, which, like, if you're just writing something without Redux, then it seems simple at first, but yeah. So the way to overcome that is, like, there are some libraries that exist, which I can't recommend because I don't use any of them. Yeah. Personally, my way of dealing with these kinds of repeated complexities is to write a little bit of code that deals with it. So like, try and keep your code like nice and neat and dry, and then eventually you'll be able to say like, oh, here's a pattern. I can just like take it out and put it over there and use it again. So just like, that's just like clean coding and dry coding. But yeah, it is something you'll bump your head on most likely. Yeah, that's it.
So
Can I go now?
Can I go first?
You can go first.
So firstly, I just want a disclaimer. I have used Redux. I have never, ever used Redux inside React. So just so you know, but the first time I had to do something in Redux, I hated it. I thought it was the worst thing ever. But that's because of the steep learning curve. Like, we can all agree on that. It does have a steep learning curve. That's definitely something we can agree on. But once you learn it, it's amazing. In my opinion, I think you can do so much with it. Like, you can scale it to make a system that works really well, though. At least that's my opinion. But again, yeah, all of these pitfalls and all of the cons are, I think, based on the fact that it has a steep learning curve, and you have to actually figure out how to do it first before you can use it.
You see, there are a couple of questions rolling in.
Please can we allow Mike?
I'm going to answer the question that gets rolling in. You don't get off the hook that easily. So I love Redux. I really, really do. And everything that Sheena and Rudy said is correct. But Redux is designed to solve really hard problems simply and elegantly. You should not be using Redux as the first thing. Like, you don't reach for the chainsaw in your toolbox immediately. Like, you first figure out whether you need to use a chainsaw for that exact job, right? It's an expert tool that you're going to run into. Fact. If you are just making API calls and showing data, you don't need Redux. You don't need anything. You don't need a framework. Don't use a framework. Just use JavaScript. Okay, end of story. We're done with that discussion, right? If you're dealing with forms, you don't need a JavaScript framework. You should be in the previous one, which is MVC, because MVC is really good at easily dealing with forms. Don't do it in Redux. Okay, you're using the wrong tool for the job. I think it's important to know where Redux came from, because you remember in the previous part talking about Facebook's MVC. Sheena was like, no, but Facebook's MVC is so confusing, right? Because they wanted to send data from the view to the model and model to the view, and everything was confusing. And that's why they created Redux, right? Because their data space and their interaction space is so complicated. One thumbs up like need to change five things on the page. And that's where Redux is really useful. That sort of like page level cross component, completely divorced from context, in my opinion. But you will hit people who are like, oh, Redux was the new shiny, so we're going to use it for everything. And no, that's wrong. Yeah, exactly. It's not Redux's fault, right? It's still, as Jerry said, it's useful way beyond React. So I've got 2 points. And the first one, I think we're gonna go to Tabiso again and answer this question. As a React developer, do you really need frameworks like Redux or patterns like Flux if you can just use React hooks? I'm going to address the elephant in the room contentiously. React hooks are Redux. They are Flux pattern, with a whole bunch of niceties that Facebook uses to hide the complexity of Flux pattern from you. But like they literally call the hook use reducer, right? It's just like a cut down version of Redux that doesn't have as much functionality and takes up a lot more space in terms of JavaScript. So,
but far less boilerplate. So there's that.
Sure.
Yes,
Yeah. Absolutely.
Personally, I
Really,
use-
you mute, but it looks good.
Sorry. Yes, thank you so much. Far less boilerplate, but also there is a cost to it because nothing is ever for free. We like to use hooks, and it makes life simple and it abstracts certain things. But introduce something in display components or view components that shouldn't be there, because now there's a combination of your state where your simple visual components need to be. It comes at that cost if ever you are not managing the situation a little bit carefully. And thus comes the learning curve, that if you are putting these components in your application, you understand what you're doing. So, because that thing might just come and bite you later. I know.
Yes,
Yep,
definitely.
got it. So remember the pin that I put in earlier? You remember that one? Okay, and that pin was basically like MVC is inextricably linked with object-oriented programming in my head and heart, right? How I've learned it and how it was designed. Let's talk about Flux, because in many ways, Flux is inextricably linked with functional programming. That's why actions are completely stateless, right? There's pure functions that take in something and return something. You're doing an immutable copy when you copy data to the store.
Correct.
The unidirectional flow of data, all of it is just a function calling a function calling a function. So, is the steep learning curve the learning curve of functional programming, or is it the framework? Because functional programming is big brain stuff, right?
Because we all come from object-oriented backgrounds and we don't actually know functional programming. So MVC is easy to grasp us. But while Ruddy was actually speaking about the whole learning curve thing and how it's a bad thing, so we've already said multiple times it has a steep learning curve, right? But if you think about it, teaching students the MVC pattern, for them, that was a steep learning curve too. Like, we just think that MVC is easy because it's what we grew up on, it's what we always done, what we always. Yes, Ruddy has stuff to say.
It's just because like Stream doesn't have a hands up kind of emoji situation, so I'm just gonna wait.
Just
And
interrupt
sorry,
me,
just
it's fine.
continue.
Don't
No,
worry.
please, no, no.
Go like this.
I'm just gonna raise my hand and wait. Continue.
Okay. No, what were you gonna say?
Okay, so I think I see where you're going, and I want to also answer that question that Mike just posed based on what you just said, because I just had a thought about it, is that there is a natural way, especially, and this is my experience, right? From varsity being taught object orientation, that MVC was not such a hard stretch for me. But and the thing is that that background was already instilled in me, that I didn't have to work hard at it, while Flux has that. So if ever I was given an opportunity to learn functional programming as my inherent like learning paradigm or architecture, maybe this Flux pattern wouldn't have been so hard for me to reach to, or like understand, or like learn and things like that. So there is an inherent way in which we learn that actually forces certain things that like force us to think in a different way a lot harder, while actually they are not. And as you said, like, you know, there might have been a learning curve for MVC, but we all know that we have an object-oriented background to whatever way you started coding, because everyone teaches you OOP. If they taught me functional programming, it wouldn't have been that hard.
I'd love to know what everybody's opinion is on the context API in React. You know, and using that as a thing to help you with state. I see Mike is chomping at the bit there.
Somebody else. I'm muting myself.
I can jump in.
So there's a question in the chat that actually asks about the context API. Maybe we can put that on the screen. And just speak to it as well. Mike.
No, let's just speak to it. Let's just speak to it. Okay. So it's a good question. It really, because like the context API is different because it's a stateful API, right? It's not a Flux API, because like you're basically saying, here is this object structure that I'm sharing with this deep nested hierarchy of components that are composed, and any one of them can pick that top level state object and use it, right? Potentially update it because it's just a reference. So I feel like in many ways, the context API is sort of React's escape lever for two-way data binding in some contexts. I know that's a bad explanation, but like that's how it often gets used. I think the context API, like when I write React components, that's my go-to. It's wonderful, and I think you can get for the Reduxy stuff that you want. You can get 90% of what most people want to use Redux for out of the context API alone. But the last 10% you will never get out of anything except Flux. And
yeah, I think that's a great point. I think for those of you who aren't familiar with the context API, the place where it often gets used out of the box is if you import some sort of styling library and it's got a theme. They often use the context API for you to be able to set the color palette and the fonts and that sort of thing on the context API. So it's basically like a giant key value pair dictionary, but can also support the nesting.
I think you can put a whole object on there. The whole object.
Yeah.
I've done it with the whole object.
Yeah.
The how I got introduced to a context API was actually through Mike. And the concept of prop drilling, which is, I think, something that is worth talking about, especially when React is being discussed through Flux, through Redux, and all of that, is that if ever you have seen yourself passing props to child components to child components to child components, especially if ever what you only want is actually a view display kind of functionality, like there is no interaction in that page of any sense. All you want to do is just get data displayed into the page. Context API can really help you in that sense, because you can use it to actually wrap all that information that you want to pass through all those child components, and they don't need to be sending data back and forth. So I found it very useful in that use case.
Yeah, absolutely. You don't need Redux in that example. You just need the context API, right? It's a different tool that you're leaning for. So well said, Rudy. So we've blown our budget, right?
Yeah. I just wanted to have one more thing about this one.
Let's keep going. Let's keep going. Yep.
Like Redux is great. Like Redux has a purpose, but let's remember that this pattern, the Flux pattern, the unidirectional flow of data pattern, is not just Redux. I mean, Redux is the most popular one, but and if we think about it, so a lot of people don't like Redux because it's gotten a bad name because of its steep learning curve and all those bad parts of it. But if we think about it, the way that we build web things, when they become more complicated, they actually end up following that pattern anyway. And I guess that's what you were saying, Michael. That's how like Facebook came up with Redux, right? Because they were moving away from MVC into some other weird thing that they didn't know what to call, and that's how they ended up in the situation. So I think that large websites will always tend towards that pattern.
I think that's a good shot, Jerry, because and that's why we've now focused on Redux, right? Because we're all intimately familiar with an implementation of Flux pattern. But Rudy, you shouted out MobX, right? Which is a stateful state management pattern, which uses observable. And in many ways, the observable pattern in reactive programming is an implementation of Flux, because the way that you push onto that observable and the way that you read from the observable are disconnected, right? So when we're talking about Flux, we're talking about that unidirectional flow of data, which I think is a really important point to keep in mind. So good shot.
And also, we spoke about AngularJS earlier. Angular 1 was an MVC pattern. They figured out they couldn't sustain it being MVC, so they created Angular 2 and onwards. And what pattern does that use? It uses the Flux pattern.
Yep,
so, sure, and like Angular diehards would eat us for this, right? Sorry, Ryan, go for it.
No, I was just going to say I can confirm I'm currently working on an Angular 1.8 project at the moment. And I had to, there was a lot of knowledge that I had purposefully tried to forget and quarantined off in the depths of my mind that I had to pull out. And it's like, what is it? Oh, it's got this controller and service, it's like all sorts of crazy stuff. And I think the move, I'm not a big fan of Angular, but I think the move away from MVC was a good thing on their part.
Okay, so perhaps do we still have stomach for complex stuff? Do we have 15 more minutes? Let's do it. Okay. Sorry, everyone, we're going to go 15 minutes over, but I think it's very clear. It's not my fault. It's Sheena and Rudy's fault. Such a compelling presentation on Flux. All right.
Thank you.
So the last one that we just want to touch on, and again, remember that this isn't the book definition of this stuff necessarily. This is how we see this pattern manifesting in the world. So we're going to talk about event-based architectures, and particularly something along the lines of PubSub, right? Which is what people are mostly going to think about. And there are some very specific examples of this, but like PubSub is relatively generic enough. Now, all event-based architectures revolve around the idea of there is a message bus, right? And instead of like a unidirectional flow of data, we now have a spider cardinality flow of data where anything can be a publisher and put something on the bus, and anything can be a consumer of a particular topic and say, hey, I'm interested in this. I want to receive it. and I will receive every message related to this thing. Things don't necessarily just have to be one or the other. They can be both at the same time. They can both be a consumer of one message and a publisher of a completely different message. And without getting into some specific examples, it's going to be hard to explain at like a theoretical level. So we're going to start off with a front-endy example because, hey, believe it or not, the browser works off of messages and events, everything. Mouse events, click events, everything is event-based. So basically, if you look at document events, document.body or any individual part of the page is like a message bus. And what you can do as, for an example, for a shopping cart, right, where you've got a whole bunch of items on the page, if somebody clicks the button, you can just go document.body.dispatch event add, and then here's a JSON bag of data that I'm adding. And that'll go into, so message A will then go into the document.body, and then anybody who goes document.body, which is the element, it can be any element, right? So you can scope this wherever you want. But let's use document.body as an example. So document.body.add event listener, and I'm going to listen to the add event. And any add event goes into this function. I'm going to do something with it. Okay. So whenever somebody clicks the button, both analytics, which is some amorphous JavaScript file that does, I don't know, some Google Analytics stuff or something, and the shopping basket component, the little icon in the corner, are both going to listen to that event. And they're going to say, cool. Now, on the analytics, when I get that event, I'm going to publish it to Google Analytics saying, hey, somebody wanted to buy this following product. I don't know whether they succeeded. It doesn't matter. But here, they tried to buy it.
They're tracking
or they tried to add it to the basket. Yeah, they're tracking you completely. And then on the shopping basket component, you can say, well, somebody asked to add this thing. Let me add it to either their session state or make some API calls or something and operate on it so that I can update the basket because they've tried to buy a product. And then when that's done, we can say, cool, well, when I've finished our part, we can confirm that we're done, right? Let's fire off another event that says, we have added an item to the basket, and this is the number of things that are in the basket. And then all the various UI components that are reliant on that can listen to that event in turn and then respond to it. But you can get a sense that like this thing blows up in terms of how many events and how many things can listen to how many events. And I think fan out is often used as an example of this. But this is just one example that is not uncommon in a shopping cart context. And before we move on, I just want to point out that like this is something that you can do without needing a framework. This is in your browser because this is how your browser works. When somebody clicks, it publishes a click event on that element to everything that subscribes to click events on that element. But understanding the sort of spiraling complexity of message-based architectures or event-based architectures is not just on the front end. There are also use cases on the back end, which Ryan's going to take us through.
Cool. So I'm one of the few JavaScript developers who does almost no front-end development. So my focus tends to be on the back end. So I figured I'd put together an example and show you just how simple it actually is. So what we're going to be simulating here is a fairly standard use case where you would have a folder and you would build something that's just going to watch that folder for file drops. So this is fairly often something that happens where you're integrating with a legacy system and they're on an AS400 and they can't build the REST API to do stuff. So you just kind of want to get it done really, really quickly. So I'm not going to take you through how to build a file watcher. If that is something that you're interested, please reach out and I can help you with that. There's quite a few open source libraries that'll do that as well for you. But I'm just going to be taking you through how the eventing would actually work. So in the example we're going to go through, we're going to publish some sort of analytic metric. So we might want to track how many files have been processed over the course of the day. And then we're going to process the file in a very complicated way. And I just want you to be aware that on the back end, you might actually want to have multiple different event emitters that handle different responsibilities. Or what I often see people doing is putting everything on one event emitter and then letting everything handle that. I've seen it work. It can work, but it's not very scalable, and I don't recommend it. And as with everything in software engineering, a big part of building a good system is knowing where those system boundaries are. So those of you who are familiar with domain-driven design, you can apply those same principles when building your buses, so that you can separate out those concerns. And remember, you can always rebroadcast an event from one event bus to another one. If we can just go to the next slide, I'll show you some code and my beautiful theme. If anybody's interested in this code, I'll upload it onto the show notes, put a link, maybe I'll dump it onto GitHub. But I just wanted to show you that in 31 lines of code, you can get a very simple event bus up and running. So it all comes from the built-in events library, which is part of the Node.js API. I think it's been around since the very beginning. You basically just new up the event emitter. If you are slightly insane and you're using classes in JavaScript, you can also inherit from the event emitter and write your own one. I am a little bit biased on functional versus classes, and if you want to fight me about that, we can meet outside after school. I see Mike's got some strong opinions, so maybe we'll do a show on that a bit later. Then basically the event emitter's got the .on, which you might be familiar with from the front end. And it's just basically a string that uniquely identifies, or sometimes doesn't uniquely identify if you don't put them in a central place. And then you end up with the same event with two different types of payloads. So I would recommend that you actually create a event types file that just has those key value pairs. You basically listen to the event emitter by saying event emitter.on, and then it receives a payload. And you can actually pass multiple parameters in there, or you can lump everything into one context object. It's up to you. Obviously, if you're using TypeScript, you can get some type information on that. And if you're just using pure JavaScript, you can use JSDoc to get some extra typing on that. And then lastly, if you would like to broadcast an event, you simply call emit, and you provided the name of the event and the payload that you'd like to pass. And that'll actually broadcast it. And you'll see in this particular example, we've got two consumers that are listening to the same event. So the first one on line 7 there is basically simulating the stats. You could then pump that into Prometheus, or if you've got an Elk stack running, or SQL, whatever you wanted to do with your stats, you can do that. And then the second one simulates processing it. So it basically just awaits for 4 seconds and then will emit a new event to simulate that the processor has put that file back into the same directory. Don't recommend doing that in production, because then you're going to get an infinite loop, which is why I've got the number of times in there just to short circuit it after it runs through 3 times. Now, important thing is now, in a distributed programming scenario, you might want to listen to an event bus that's on another server running in Node. If you're going to sort of branch out into that sort of complex eventing, you might want to look at an event-based system like Kafka. But if you do want to use it in Node and you're doing something fairly small, you can actually achieve the same thing with WebSockets, so that the event emitter can publish events to the WebSocket. You can also do long polling if you don't have a lot of time, but just to show you how those are there, how those could potentially work. And we're going to go on to the pros and cons now. So it's very loosely coupled. You can publish a whole bunch of events and there's nothing that's subscribing to them. You can build those later. It's like we're gonna add support for user clicked on help me, and we haven't had the time to build the help me thing yet. So you can add those event consumers at a later stage. And if you're storing the actual events in a queuing system, you can build up those queues over a couple of days, and then when you release that new functionality, you'll go through and process that. Obviously, that's not a use case that you can use if it was for a front-end event and you now want to start handling those. But it's interesting to note that is a way that you can handle it. It does scale incredibly well. You can add as many listeners as you need. If you add a queuing mechanism, you can have those providers actually, the consumers actually processing the queue rather than the event bus directly. It's very easily to extend. So if you've got something that when a user registers, we send them a validation email, and now a couple of months later, you need to also send them a validation SMS. You don't have to go and interfere with that existing code. You can just add a new listener that listens for the exact same event. And this is one of the most mature technologies around. It's been around for nearly half a century. It's tried and tested. There's lots of examples, lots of people you can ask. Because it's not so new, it actually doesn't get that much play, but it's incredibly powerful system. And I really like developing in event-driven design. Some of the cons, complexity can be quite high, especially if you think about it, like you're sending an event off into this message bus and you're like, how do I follow the stack trace down? Like, what is going to handle this? So you like find in solution, name of event, see if you can do that. There are ways to mitigate that. Like I was mentioning earlier, if you have all your events, all your event types in a file, you can in VS Code find all references, see where it's actually used. So there are ways to mitigate it, but the sort of thought process is it takes a bit of getting used to. Analytics on number of messages handled doesn't translate as well to those of you who are familiar with number of REST requests, duration of request. Because if you think about it, if you send a request to the server and you're using WebSockets and you say, process this message, it's going to return almost immediately and say, cool, I put the message on the bus. You don't know how long the side effects are actually going to take. So it can be quite tricky to figure out, we've got some sort of performance bottleneck in our system. What's causing it? Okay, well, you kind of got to go digging. So your analytics does become a little bit more tricky. Whereas with a standard REST type model, you've got the request start, the request end. So everything along that pipeline took this long to execute. If you are using WebSockets to interact with the event bus, it can add an extra layer of complexity, and it can also increase costs. If you're building stuff in AWS Lambdas, for argument's sake, that you're only paying for while that thing's actually active. Whereas if you're using WebSockets, until very recently, you had to have the server running the whole time and keeping those connections alive, which can add extra costs. I was doing a bit of research earlier that AWS has released WebSockets on their API gateway, which is quite an interesting thing, because then you can have the WebSocket and have the API gateway paying for that and executing Lambdas to do the logic in the background. So that's something I'm going to be playing around with in the next little bit. And yeah, that's it from me.
So it feels kind of unfair and disingenuous to have the complexity as high on this and on the Flux pros and cons slide, because to be super clear, there's an order of magnitude difference in this is complex from Flux to event-based architectures, because Flux at least has a pattern, right? It's got this is how thou shalt do things. Event-based architectures basically take that and chuck it in the bin. They're like, whatever.
Yeah, but we do JavaScript, so we're used to the dynamic whatever. We'll build it the way we see it. It'll evolve.
So that's a really good point, right? Because a lot of the stuff, specifically in browser, makes a hell of a lot is really easy, because the hard problems of distributed computing become simpler in JavaScript, because JavaScript is single-threaded, right? It's got one event loop. So you can guarantee the order in which those events are going to be fired. As soon as you're going over a WebSocket or putting it on a message broker that's externalized, suddenly your consumers can't guarantee that they're going to get the messages in the right order. So let's say somebody hits save on whatever, let's say it's a form. You shouldn't use this for forms. Don't anyone ever say that Mike said you should use this for forms. It's a bad idea. But let's say you're using it for a form, right? And you hit save and somebody's like, oh, damn, I'm going to go and edit and quickly change my surname and hit save again. And then you can't actually guarantee ever that those two messages are going to come in the right order. So every time you deal with something, you have to be aware of when it was sent and whether there's a more recent version of the set, which is a mind-bending problem. and it's incredibly powerful. But Jerry, like, you deal with this stuff.
Yeah, so one of the things I was gonna say is on the one hand, one pro that you forgot to mention is that all of the other patterns we've talked about is stuff that it's so easy in this kind of architecture, the event-based architecture, to retry something if it fails, right? But on the other hand, if you don't write your code properly, retrying something may be very dangerous because you might end up paying for something twice, or creating two users, or all of those kinds of things. So idempotency becomes very important when you're building a distributed system. As Mike said, I've had problems like this recently, so I know how important it is. Anyway.
So let's be real, right? The real world is complicated. Real software is complicated. And when you're writing real software, when you get to the point of like, oh my word, I cannot hack this through in MVC, it no longer works. And I can't use an opinionated pattern like Flux. Eventually, at some point in time, you're going to deal with high volume, high distributed complexity in a non-homogeneous environment with different languages and runtimes. And in that world, you're going to use event-based architectures. Fact, eventually.
So one thing I thought of a question for the group. So we were talking about MVC, and MVC is a pattern that can be implemented both on the back end in servers as well as on the front end. We were talking about the event-based architectures, which is a pattern that can be implemented both on servers and on the front end. But I've never heard of Flux being implemented on a server. Does anyone know of examples or libraries? Or I don't know, I'm asking.
Unfortunately, yes. I can't recommend it.
Okay, so it's not a good idea.
Okay.
They wanted so much to know if they could. They didn't stop and think that they should.
Rudy knows what I'm talking about. But like, it's because Flux, again, is to solve a particular problem, right? It's an opinionated way of doing this stuff, which doesn't translate to server-side. And I think on that point, like there was a question, a really good question in chat, which is event-based architectures related to reactive programming? And like, I think you can put reactive streams on top of events, but I don't think that it's common practice because of the challenges of that event being out of order, potentially. And stream-based programming is very much, you can guarantee the sequence in which things come. So I think that reactive programming, particularly as a client-side pattern, is very closely related to Flux and how Flux works. And reactive programming in a server-side pattern is its own beast entirely. Like it's very different. And I don't feel qualified to talk about it. If people are interested, we can go find Rory and get Rory to talk about it.
I have
Sheena, you wanted
a
to say
response.
something? Oh.
So I have a response and a question, but Sheena, do you want to go first?
I was just going to say, with event-based architectures, I think you probably have to be very disciplined in your approach to when you fire events, because like there's some serious problems that you can have. Like if you like fire an event and then that triggers this event to be fired and then it cycles. I'm sure that is something that's probably happened a lot to anyone who's ever used event-based architectures, and it sucks. So yeah, like with great power comes great responsibility, basically. Yeah. Rudy?
Thank you. Yes, that's very true. There's something that Mike mentioned in terms of like the complexity when comparing Flux and event-based architecture is that there's something that I just thought about the fact that for me, Flux feels like it's an artificial complexity where you are forced to think a certain way, while event-driven, you inherently have that like with you or naturally because it's JavaScript. You just need to know how it's put together. That yes, it's complex in the sense that we don't normally actually use it in our like forever glorified frameworks, and we always want to kind of use it using some form of abstraction. But the Flux version of it is the artificial new one that we don't know about. While event-driven, that's how the web works. Like it kind of feels like it's something that we should understand and that should make sense. It's just that we've never actually, or most people have never like used it in their everyday programming. And then the other question that I had for Ryan and Mike, because of the event-based driven, which I don't know if ever other people have that question, but I know the difference. But how would you differentiate between actions in Flux versus event in event-based, and how are those different?
That's an interesting question. I don't think that they are very different, right? I'm sure you can find an argument for them being different, but I don't think so. I don't think they are very different.
They're both like a plain object that might result in a side effect if you specifically go ahead and code it up. But yeah, they're actually quite analogous.
Yeah, I think basically you can think of like event-based architectures as if you take the reducer out of the front end. Okay, there's no reducer. Everything is its own reducer, which is a consumer, right?
Fair enough.
But that's insightful.
So one thing that Ryan mentioned was Kafka, and I don't know Kafka very well, but we have Mike and I have actually implemented a POC using Redux and on the front end and Kafka on the back end, which is the Flux pattern on the front end and an event-based pattern on the back end, and it actually worked really well. The two worked very well together, and that's what your question really made me think of that.
I think the team over at Simply is doing that as well, if I'm not mistaken.
Yeah, it worked. It worked really well, and I think those two patterns can work well together.
So we used Redux on that POC. I'm just saying, it was wonderful.
Didn't we use React too? Actually, I was lying earlier. I do have React and Redux experience.
I wasn't going to tell you. It's okay. One last point, I suppose, that eventing and event-based architectures in the front end opens up a really interesting paradigm in terms of the fact that if you use web workers fundamentally work by sending messages across threads between the main thread and child threads. So event-based patterns in terms of web workers immediately opens up multi-threading for front-end apps. Think about it, right? Like, it's phenomenal. Like, this is the pattern that you use when you get to the point where you're like, okay, my website is janky and slow because I can't run enough JavaScript fast enough because I've got one thread. I'm going to take the next level. And when you know you need to take that next level, this is the thing that you're going to reach for. It has to be, because that's how the thing was designed.
But don't reach for it too soon, because you will end up in a bad place.
You will, yeah, fact. Okay, awesome. Any other insights from anyone?
I have not an insight, just something I did many years ago, which has jumped into my mind. So it wasn't exactly an event-based architecture, but it's similar enough where like sort of requests were fired by different things to each other, and it got hideous and complicated and confusing. And what I ended up doing was just attaching IDs to the messages that got sent out. And then, like, if I'll get a message and I need to fire off a bunch of other messages as a result, then I'd say, like, okay, cool, I'm going to add that message ID onto all of my messages I'm sending out now and add another ID that's unique now. And then if something does get weird and cyclical, and you have a way of recording all the messages that get sent, full stop, like all of them, and access to that, then you can get like a chain of, like you can get a visual of how everything related to each other. And I'm wondering, like I was kind of a bit of a noob there, and I wrote everything myself, which was probably dumb. I'm sure that there's something that does this. Are there awesome tools that you can use for like making sense of chaotic messages?
Yep. There definitely are. Not necessarily in the front-end space, so not like JavaScripty stuff that you can use in the browser, but like that concept is the idea of correlation ID, like each message having a unique identifier and being related and replies and downstream messages and blah, blah, blah. I think if you use a message bus like RabbitMQ, I think there's some of that visualization that happens, and there are tools that you can use on top of RabbitMQ to visualize flow of messages. Pro tip, that the more useful they are, the more expensive they are. Because it's a complicated space that real software sits in. So you'll find that when you reach this point, like you're not going to accidentally reach this point. There's not going to be a beginner tutorial that gets you to this point. When you are there, somebody's probably going to need to buy something. But it's a good shot. Cool. So to everybody, that's the 24 of you that have stayed on for the hour and a half that we've argued about architectural stuff, I'm impressed. That's some serious commitment. And thank you very much for listening to us badly explaining architecture. That would have been a great title for this. Badly explaining architecture.
Missed opportunity.
Really is. I can go and edit it afterwards. So if you disagree, or if you're watching this video retroactively and you found us on the internet and you decide that we are wrong, please argue nicely. We haven't given this the book love that it probably deserves. Each one of these is hours worth of education to go through in precise language. We've tried to explain it as accessibly as we can through lived experience as to how we're accessing this stuff. But if you do think we've misrepresented anything, please let us know. If you've got any questions, please let us know, and we'll try and reply with answers. And normally, we've done this 3 times, right? So normally we would tell you now what the next month's session is going to be about, but it's been a week, right? It's been heavy, and we don't have any ideas for next month's session. So if you folks have any suggestions as to what you would like to hear us ramble on about and explain badly next, please put them in either the chat if you're here, or put them in the comments below, and we'll try and grab them and run with it next month. So
just quickly before we say goodbye, I'm wearing my Microsoft jacket. So I just want to say the Azure Bootcamp is happening at the end of September, on the 30th of September. And if you have an interest in Azure, please go to azurebootcamp.co.za, submit a talk, or just attend. It's virtual. It's cool. It's going to be cool. It's going to be cool stuff.
She definitely wasn't paid to say that. She was just asked nicely by somebody who's very nice, who we like. Okay.
So someone who gave me this jacket.
Nothing is for free, Jerry. Okay, but that's a good shout. If anybody else has any community stuff, let us know, and we'll shout out. You know, the community's struggling at the moment because, well, gestures at everything. So let us know if people are doing anything. I know front-end dev SA is trying to organize a conference. So, yeah.
Oh, and Linux Conf is also happening in October.
Yeah, open source week is happening in October, which is cool.
Yeah, all virtual.
Cool. That is cool.
The call for papers is still open for that one too.
Yeah. Okay, so that's a good shot.
Sweet.
Okay, thank you very much, everybody. It was awesome chatting with you and explaining architecture badly. We'll catch you on the flip
Thanks,
side.
everybody.
Cheers, everybody.
Cheers.